Okay, let's get started. Right. Just to get warmed up a little bit, I'm going to give you a quick long division question to do. So what I'm looking for, just to get us started, is I want the remainder when, let's say, x cubed plus x squared plus x plus 1 is divided by x minus 1. See how quickly you can divide that. Yeah, the remainder. No, it is not. Remainder is 4. Did you all get a remainder of 4 yet?
Almost.
Almost? Yeah?
Yep. Yeah.
Did you all get a remainder of 4? Yeah? Yeah? So, what's wrong? Tommy, did you get a remainder of 4?
I'm trying to like compare like some of my works like this and this for like I don't know, maybe this is wrong.
What remainder did you get?
It's not even that. It's even like another like equation. It's like maybe you might understand what happened here. I'm not really sure what happened.
No, I don't want to see this website. Just do it the way I taught you.
Yeah, I was trying to, but I got confused sometimes. So like,
Wait, let me see that again. What? You mistyped the question in. That's what you did. You need to put brackets around x minus 1. Class rep, everybody. Class rep.
You're welcome.
Yeah, all right, okay. Making the mistakes so you don't have to. Okay. Right, so what we're looking at here, you all got the remainder of 4, but you all got this by using long division, right? We will discover a quicker way to get the remainder, okay? Now, I'm going to give you a proof now. This proof is... It's kind of long, so you really need to pay careful attention. Son, you need to pay careful attention. I'm going to give you a proof now, and it's kind of long, okay? Can I scroll down?
Yep.
Yeah. So what I want to know is, can I figure out a formula for any cubic like this? I have a cubic like this, and I want to divide it by, let me call this cubic f, for example. Fx equals this. And I want to divide it by, let's say, x minus k. Do you understand? I am trying to find a formula. Remember how we found the formula for the quadratic? Minus b plus or minus square root. Remember this? Yeah? So let's see if we can find a formula with a, b, c, d, and k. A nice little formula that will give us the remainder. Okay? Let's see. So the proof, like I said, you have to pay careful attention. Let's begin by doing the long division. X minus k divided into ax cubed plus bx squared plus cx plus d. Now, we'll do this step by step. We'll do the first multiplication, then I'll pause and let you write it down. Okay? So what would be the first term here? ax squared. Now let's multiply it. What do we get? Ax cubed minus a k x squared. Now, no, don't write this down just yet. Just pay attention and then you can write it down after we do the subtraction part, okay? So, these guys cancel. Now, here, the b and the ak add because they're coefficients of x squared. For example, if this was a 2 and a 3, then it would become, obviously, 5. Yeah, so what would it be? Bracket b plus ak x squared plus cx plus d. Now, are you okay so far with that? Alright, so what we'll do, we'll pause for a minute, write this much down, and then we'll continue with the next multiplication. Okay, so write that much down. So, we're all happy up to this step. Yes? Yes? Okay. So now, on to the next stage. Being careful, what will need to be the next multiplication here? B plus AK X. Now, let's carry out the multiplication. What do we get here? B plus AK X squared. Good. And then next is minus. Yeah. B plus AK K X. When this bracket multiplies the K. Yeah? Now, subtracting happens here. And what happens here? They add. Now, what I'll do, that's a C bracket, and this minus will become plus, and I'll expand this. So that would be B times K, so that's BK, and then the next one, and this is the coefficient of X, and at the end here, okay, so it's, you can still understand it, it's just getting a little bit long, but don't worry, that's stage 2 done. There's only one more left. Okay, write this one down. Well, how many steps? How many stages left? Well, one stage left. Yeah. You did it. Yeah. Carefully.
I'm waiting for your answer and check.
Okay. We'll see. Okay. Last stage, and then we'll have the result. What is the multiplication we need to finish this long division? C plus BK plus AK squared. Now, we'll carry out the multiplication. So that will be C plus BK plus AK squared times X. And then minus bracket c plus bk plus ak squared k. K, yes. Now, let's minus. So these cancel. What happens to this minus? What happens to this minus? Comes plus. So the remainder is d plus c times k plus plus. Now that formula doesn't look too bad for the remainder, does it? But it gets better. So I can rewrite this remainder as ak cubed plus bk squared plus ck plus d. Looks familiar? What does this look like? This is fk. So what is the result here? The result is the remainder will equal the function, the cubic, but instead of using the value x, use the value k. This is the remainder theorem. That's what it says. That the remainder is the cubic at the value k. That's what the remainder is. Now, before you write that down, let me show you. Remember this one you did for me? According to the remainder theorem, the remainder should equal the function when x is 1. Well, minus 1 makes x equal 1. It's kind of like this. Yeah? So if I put 1 in here, 1 cubed, plus 1 squared, plus 1, plus 1, total 4. What answer did you get? Remainder theorem, yes. It's wonderful, isn't it? Okay, so finish writing that down. I bet Joan didn't show you that proof, right? No, she didn't. She doesn't like doing proofs in her class. I know this about her. I know, aren't they missing out? Missing out so much. Now, what do you do in situations when you have something like this? Divide by ax minus b. What would you use in that situation? You wouldn't say b by itself.
B over A.
Very good. B over a. In that situation. Yeah? Yeah?
What if the divisor is like a quadratic too?
Yeah, it doesn't work. This only works when you're dividing by a linear. I mean, I'm sure there is a version when you're dividing by a quadratic, but for this course we only worry about using the remainder theorem when we divide by a linear. I mean, you could do it as a quadratic, but you might have to factorize the quadratic first, you know. Okay. Do you have that remainder theorem proof? Yeah. It seems useful, doesn't it? You now have a way to calculate the remainder without needing to do a long division. Right? So that seems like it's a useful thing to do. Can I scroll down?
Yeah.
So just some quick examples first and then a longer example. So a quick example here. If I say 2x minus 7 is the factor, then what do I say is the root? X equals 7 over 2. Okay, that was a quick one. Another quick one. If I say minus 5 over 8 is the root, then what is the factor?
8x plus 5.
8x plus 5, isn't it? Okay, so you're all right with the basic stuff here. Now let's go on to a more difficult one. Well, not difficult one. I'll give you this one to try. I want you to use the remainder theorem to tell me the or when 9x cubed plus 29x squared minus 28x minus 3 is divided by x plus 4. So take out your calculators and give me the remainder here. So the remainder will equal.
Minus 3.
Do you all get minus 3?
Yeah, minus 3.
Yeah. Okay. Okay, write that one down now.
Minus 3.
What's wrong? You guys laughing at Danny again, isn't it?
They're always laughing at me. I don't know what I need to do. They're always just laughing at me.
Right. Find P if x minus 1 is a factor of 3x cubed minus 9x squared plus 14x plus p. Now, the key word here is actually factor. What is useful to know if it is a factor? What is the remainder supposed to be? 0. Right? So I think if you know the remainder is 0, and you can use the remainder theorem, 0 is supposed to be the answer, yeah. I think you can figure out what the p should be. Go give that a try. You got p is minus 8?
Yeah.
So when you put in 1, isn't it? 3 times 1 cubed minus 9 times 1 squared plus 14 times 1 plus p should equal the remainder, which should equal 0. So you got p is minus 8, did you say? No? 3 minus 9 is minus 6.
Plus 14.
Yeah, 8, is it?
Yeah,
Yeah.
minus 8.
Minus 8 then. Okay, so that's the p then. Fine. Now that question is a little bit too easy for the exam. It's too short. The next question I'm going to give you will be more suitable as an exam question. So really, up until this point, we're just kind of doing warm-up questions. The next question is more like an exam question. Can I scroll down? Yeah. Okay, so px cubed plus 17x squared minus 4x plus q. When you divide that by x plus 3, the remainder is minus 240. And then the same thing again, px cubed plus 17x squared minus 4x plus q. When that is divided by x minus 3, the remainder is 5, 4, 6. Find P and Q.
Simultaneous.
That's exactly it. Yeah, give it a try. Did you get answers?
15.
15 is one of them, yeah.
Yes.
And
For the other one?
0.
Oh. Yeah. You got 15 there?
0.
Still something else in question 1 and question 2.
Yeah.
Yeah, and Q is 0.
Good job. Good job. It's a simultaneous problem, isn't it? Yeah? Did you spot your mistake? Or?
Oh, what's it?
Yeah.
Okay.
You'll find it. The P is 15
Okay.
and the Q is
0.
0. Yeah. Now, let's quickly do this one. So, what do you do first? What do you do first?
But the equations.
Yeah, well, sub in what value of x first? Minus 3. Minus 3 cubed? Minus 27, isn't it? P. And then what is 17 times minus 3 squared? 153? Thank you. And then plus 12, isn't it? Plus Q equals minus 240. So you have minus 27p plus Q equals minus 240 minus 153 minus 12.
381.
331?
381.
381. That is equation number 1. Yes? Now, in the second one, you simply sub in,
No, it's minus
Just 3.
thank you, minus 405, yeah? That's equation 1. Yes? Now, let's sub in the next one. So, I get 27p, yes? Plus 153 minus 12? No, minus 12, isn't it? Plus Q equals 546. So now I have 27p plus Q equals what? 405. Now these simultaneous equations, these are really nice to solve. Look at this. If you simply add them, what will happen? The p's will cancel and you'll get 2q equals 0. So Q equals 0. And if you sub Q equals 0 back in here, you can get P is 405 over 27. The minuses cancel. And P will be 15. And we're done with this one. Okay? This would be a question in the exam, probably like 5 marks, 5%, something like this. Okay? They would make it, they would either do two things to make it more straightforward. Do you notice here, this simultaneous system was rather easy to solve. Very easy to solve, wasn't it? If they don't make it so easy to solve in the exam, what they'll do is they'll make the numbers very small. Okay? Because what they would like to test your knowledge of in the question is if you know how to use the remainder theorem to form a simultaneous problem. Yeah? Is that okay there with that one? Yeah? There's one more to do as an example. I don't want you to fully do it. I just want you to figure out what the key step is to get the problem started. So if I tell you that 15x squared minus 23x plus 6 is a factor of px cubed plus qx squared plus 29x minus 6. I don't want you to solve this. I just want you to tell me what would you need to do to solve it. So, any ideas?
What's the question?
Sorry, find p and q.
Oh,
So, what should we do? Yeah, we'll factorize here. Now, you don't need to do that. I just want to know, after you find the factors, then what do you do?
Use one side for P, one side for
What?
2 equations.
Two equations by using the two factors.
Yes.
And what should the remainder equal?
0.
0.
Why?
That's the factor.
Yeah. Now, before you continue, now I want you to write something down. Are you 100% sure that if this is a factor, that means this divides into the cubic, then the factors of the factor is also a factor?
Yes.
Yes.
You're saying that with such confidence you don't even want to check it with numbers.
Because that's what I did.
You checked it with numbers?
For example, if you say 60 and 30.
Okay, good, yeah. 30 is a factor of 60.
Yes.
We all agree with that. 30 divides into 60 twice.
15
And 15, for example, is a factor of 30.
Yes.
So 15 is also a factor of 60. That's the logic we're using here. If the quadratic is a factor of the cubic, and the linears are factors of the quadratic, therefore the linears are also factors of the cubic. And here's kind of a number example here. If 30 is a factor of 60, and 15 is a factor of 30, then it's also true to say 15 is a factor of 60. Now, I've never seen them ask you that in the exam. There's no reason that they wouldn't ask you this. I mean, it's, you know, the ideas here are ideas that are on the course. They tend to keep the questions more like the last one we did, okay? But just in case they decide to give you a hard one, this is what will be an example of a hard question on the remainder theorem, okay? But you all got the idea figured out here.
Yeah.
Right. So, homework then, which you can start now. 1A, 2A, 3A, 4A, 5A, and 6A.
Okay.
Aoife, you have the same book, do you?
Yeah, I can.
Yeah, like does your pages look like this?
Yeah.
Yeah, okay. Did you do these ones already, or did you do different ones?
I did.
If you look at page 24, did you do these particular ones? 1A, 2A, 3A, 4A, 5A, 6A.
Yeah. I did that.
Yeah? Okay. So, since you're slightly ahead in maths, which is a good thing, it gives you time to catch up on the physics then. So you can actually have a start on that. For the physics, what I would like you to do, there's a workbook on Moodle, and I can email you the link in a moment. So the workbook has questions on each lesson. So you know, what was our first lesson? Like vectors and scalars or something? No, dimensions and units, wasn't it? So in the first one, there'd be like I think there was like 3 questions or something. And the next lesson, I can't remember. Well, I think it was on vectors. Maybe there was also 3 questions. Now you've studied physics before, haven't you? So it might not be necessary for you to watch every video. So what I'd like you to do is, for each lesson, in the try to do question 2 in each lesson. And if you can do it, that's great. And if you can't do it, then maybe you need to watch the video and then try to do it. So I don't think it's, if your physics was good, I don't think it'd be too bad to catch up. That I'm basically giving you like about 15 questions to do for homework. So if you want, you can open up the workbook and get started having a look at the questions and see if you can do them. Trying to do at least one question from each then. And then if you decide to stick with physics then on, what day is today? Wednesday. I would think by Monday you probably should be caught up then with those questions there. So if you email me now, then what I'll do is I'll send you the link to your phone then of the questions which you can get started on now then. Okay, so if you want to email me and just put in the email like workbook or something, and then I'll reply now. So
Okay, I use the calculate to your visual assistant. So about the test.
I still don't have Moodle.
No, your account works. I checked it. I used your username.
Which one?
I told you this last week.
Where is
The Bello
the
Gmail one.
Bellu.Mustafa.
Yeah, at gmail.com. And I used the password is password, and I logged in successfully. So why don't you try it now on your phone?
Can you explain the first question?
How is
Wait,
it?
that was the first example I did. Just convert it into a fact, into a root. So it'll be 7/2. It'll be 1/5.
And
Like
then
so,
3x
like-
minus.
No, that's it. The answer is 1/5. Done.
Well, okay, cool.
How do I get the Moodle?
DIFC Moodle.ie.